I'm waiting for that to charge. There was a further complaint about the USB not working or not recognising a phone, or the phone not recognising this when it was plugged in. It's the USB tester. So that's outputting 5 volts. Try and plug my phone into it. I'll plug in my decrepit old Windows phone. No. There you go. So it recognises my phone. How much is that taking? Very little, I think. My phone's nearly fully charged. 0.45 amps. So maybe with these newer power hungry phones, maybe charging at 1 or 2 amps. Let's see if we can go. I think I've got a load tester here somewhere. Let's plug a little load tester in. Don't know what this is set to, but probably too much. Okay, just taking 1 amp. Can move that with my fingers. Ah, I see it. Anything over 1 amp and it shuts off. Let's come back in. I think I'll tap that back down a bit. Yeah, voltage drops to 4.4. Try again. I think that's your problem. If you've got power hungry charge phone, taking anything more than 1 amp, the USB module shuts down. I do have some USB modules in stock. I just wonder if they'd be any better. I'll check up on the specs for these. Apparently they can handle 3 amp. But some reviewers saying that the chip gets a bit hot over 1.5 amp. Right, what I have here, I made up a bank of barely alive cells. And I've hooked up the USB module I plan to use, and the switch, and the meter. Let's see. 5.21 volts. There was a review of these modules that said the floating voltage was about 10 volts, so I was a bit wary. Yep. Let's try that on a load. See if it'll take more than the 1 amp that the other one provided. So far so good. Come on, give me 1.5. So it's charging a phone, it's going to be on for hours, isn't it? It's warm at the moment. I'll give it 10 minutes standing. The voltage has only dropped to 4.9. So far so good. 71 degrees already. What's the limit on these chips? Something's cutting out. I think it's the inability of this to Supply 1.5 amps. Let's chop that down to about 1. Stable, that's about 1 amp. These modules are supposed to be rated for about 3 amp. Ha! 3 Chinese amps. Probably the chip was getting too hot. Getting up to about 70 odd degrees. What, 83? Yeah. Now that I've tested this module, I found that it's no better than what's already in the pack, so I won't be using that. For my own curiosity, I was wondering if I used a lower voltage pack, whether the results will be different. That's worth a try. I want to try the test on this again, but this time running off the power supply, the background, 13.8 volts. Switch on. Do 5.18. Give it a load. Let's go for the same 1.5 amps again. See if this runs for more than 5 minutes. The chip getting insanely hot. Now that's been running longer with a lower input voltage. So 13 volts as opposed to the 40 volts that this would supply on my pack in the background there. This board is still getting insanely warm. Barely touch it. It's not as hot as last time. It's getting it to 83 last time. I was hitting its thermal overload. So it's the largest we've seen there, about 60 something. 67. Seems to be hotter at the top of the tab, but yeah, still a bit warm. So it seems that these modules are much better for lower input voltage. It can handle 13 volts, but not the 40 volts. It's still going at 1.5 amp after about 10 minutes, where on 30 odd volts inputs could only manage about 5 minutes. So it seems that these boards are designed for 12 volts, better at a lower voltage input. So even though it could take 40 volts in, it doesn't run for very long. So that chip must have to dissipate a lot more power with a higher input voltage. So in conclusion, after that USB test, I won't be changing the module on this, because the ones I had are no better than what's already in it. Good for 1 amp.